Good morning and welcome back. 12.4 part 2. Now, if you haven't watched yesterday's lesson, go ahead, pause the video, go back, watch it. Okay, this 12.4 is a little bit confusing and you've got to watch it in order. It's not going to make sense. So 12.4 part 2, today we are going to add on to what we did yesterday. Same concept. Now we're going to do it about story problems. So this paragraph here says vectors have countless applications in the world around us. Vectors let us give a direction in conjunction with a value. Speed, for example, would be measured by a single numerical value, where velocity, on the other hand, includes the speed with the direction of the moving object. We can use vectors to solve problems like the ones below. Okay? So if we look below here, it says a speedboat is traveling 30 miles per hour, has a compass heading of 100 degrees east of north. So here's our compass rose, north, east, southwest. Okay, the water's current's velocity has a magnitude of 15 miles per hour, and its heading is 22 degrees east of north. Find the resultant. Okay, that's the actual velocity of the boat. So how is this boat moving? So there's one causing it to go down to the right, one's causing it to go up to the right. The combination of those will be somewhere off to the right, but is it down, up, somewhere in between? Now, think about it. First thing I want us to point out, if this was a unit circle, then east for us we'll treat as 0, north is 90, west is 180, south would then be 270. So if we look here, if this is 100 degrees east of north, started off here, that's 90 minus 100, so that would be down at negative 10, which hopefully we know is the same as, if we think about it, so we did 360 minus 10, it's the same as 350 degrees. So the original velocity was a speed of 30 in a direction relative to the unit circle of 350. So before we deal with the second vector, let's just deal with this one. So if we think about it, that means we can just multiply that 30 in. So 30 cosine of 350, 30 sine of 350. And so we're going to have 29.5442 and negative 5.209. Oops, wrong one. I don't need that. Okay, that's for our first vector. Now our second one, notice here, it says it's 22 degrees east of north. So north is right here, 22 degrees east. But if we think about it, north on our cardinal directions here, we said was 90. So if it's 22 left of that, or right of that, we could do 90 to minus 22. And the one we actually care about is 68 degrees. Okay, so we'll say it's 15 miles an hour, cosine of 68, sine of 68. So we distribute that in. And we find those, and here we got them. Okay, so 5.6191, and then 13.9078. Okay, that's step one. Okay, I know it was a little lengthy. Step two, just add those two together. So 29.5442 plus 5.6191. Okay, now if we add those together, we will get, so u plus v. For the x value, it's 35.1633. For the y, it's going to be 8.6984. And we think about what quadrant that's in. They are both positive, so it will be up here in quadrant 1. Okay, so now we need to find the magnitude. So the magnitude of u plus v, take the square root of both of these squared. And we get 36.2. So if we round 36.2 degrees, or not degrees, sorry, 36.2 miles per hour. That is the speed it's going. Okay, now we need to know what direction. So we do our inverse tan. The y has to go on top. And on the bottom, the x. Okay, and we will get theta to be, so we go here, tan raised to the -1. And let's see, it was 8.6984 divided by 35.1633. And if we round this up, we get 14 degrees. Now be careful. This 14 degrees, that would be 14 degrees north of east. We need to describe 14 degrees compared to what? So north of east. In the real world, they don't always go based on the unit circle. Okay, so 14 degrees north of east, that maybe doesn't make as much sense. On this one, they were telling us based on east of north. So if we want our start to be north, that's at 90 degrees. So 14 degrees over here, somewhere over here, that would be 76 degrees if we take the 90 minus the 14. So we also could have said 76 degrees east of north. And it'd be 36.2 miles per hour, and then one of those is your answer. All right, so that was a little bit of a lengthy problem. I know it took us, 8 minutes. We got one more of those. Today's assignment's the same as yesterday's, nothing new added on. So our plane is heading 60 degrees east of due north. It's going 300 miles per hour. The wind is blowing 40 miles an hour with a heading of 30 degrees west of north. Okay, so if we think about this one, we have our line, and it goes up to the right. Okay, so that's 60 degrees east of north. So right here, we're actually going to need a 30 degrees. So 90 minus the 60 left us with 30. So for that vector v, if we call it that, we'll have 300, and then it's going to be cosine of 30, sine of 30. Meanwhile, for the other one, remember, we're adding these vectors, so I need to move this over here. If north was still right here, then it's 30 degrees from that. So this will be our 30 degrees. So if we think for that, compared to normal, that'd be 90 plus 30, leave us with 120. Okay, so it's 40 miles per hour in a direction compared to normal of 120. So for you, we're going to get 40 times cosine of 120 sine of 120. So if we distribute that 300 in, 300 cosine of 30, 300 sine of 30, and then u will be similar, except obviously with 40 and cos of 120, 40 sine of 120. So type those in your calculator, figure out what they are. To save us a little time, I'm just going to show what I got. But if I were you, I'd pause it and try them on my own. So 259.8076. And then for this one, it's 150. Meanwhile, for u, we get negative 20 and 34.6410. Now these, all we got to do, add them together. And you might actually be able to do these in your head pretty easily. Just minus 20 from that one will leave us, if we add them together, 239.8076. And we add 150 onto the other one, we'll be at 184.6410. We can figure out what quadrant will that be in. Once again, it's up here in quadrant 1. So now, to find their speed, let's take the square root of those two squared. And if we do that, it's about 302.7 miles per hour. Now we need to know what direction is that. So once again, take the inverse tan. Y goes on top, X on the bottom. And we will find theta to be 38 degrees. Now once again, that 38 degrees would be 38 degrees north of east. That's not usually how we talk. Okay, usually we go based on north. So east of north, if we take 90 minus the 38, we're left with 52 degrees. So more common might be 52 degrees east of north. All right, so that's all I have for today. If you have any questions, this was challenging. Please let me know. Hope you guys have a great day and continue working hard. Finish strong. See you guys tomorrow.